Global consumption of energy has plummeted by 17% during this pandemic, but do we need such a drastic event to reduce our carbon emissions? Hi, this is Takatoshi Shibayama, host of the Future Design Podcast. In this episode, we're going to be talking about sustainable energy sources. Not just green energy, but bringing back nuclear in a more advanced way. We've been talking about reduction in carbon emissions for many years, but only to be scolded by a young girl to change our habits. We can't change our ways, we gotta change the system. Jimeno Fonseca, an academic at the ETH Zurich, is back on our show, and he's gonna be talking about energy generation. So stick around to the end.
Future Design Podcast.
I read on the news that global emissions during this whole period where we're in quarantine lockdown has dropped by 17%, and even for and then the world needs to reduce 7.5% or something like that until 2030 to meet that Paris Treaty Agreement. So you can think of the magnitude of how much energy we need to reduce in order to meet those targets. And I think it's kind of unrealistic, to be honest, because once we get out of this quarantine and everybody goes on with their daily lives, obviously they're not going to reduce carbon emissions. They're just going to go right to where they were before. And that's my view. But, changing people's habits is very difficult. Even if you tell them all the climate change issues and all these things, a lot of people only care about what they have at the present. So is there a way from your academic studies that you found that there's a way that we can reduce carbon emissions?
Yeah, right. Thank you, Chaka. So that's a good question. I think a very pressing question because many people think and bet on technology as the main answer to basically reduce and mitigate climate change, so to speak. That's the main problem, right? That's why we reduce emissions. But there are also other alternatives that at the end lie on changing people's behavior. At the end is about consumption. Well, we have tried to do both ways to analyze how much technology can actually help us to get up to meet those goals. It sounds very promising. And recently we started to study the behavioral question. And we tried to do some experiments even here in Singapore by trying to give incentives to people to reduce their energy consumption, subjected to a monetary reward, for example, or sometimes just a kind of a reward that can be sensed in terms that they are helping the environment, right? And what we found out is that despite people's commitment, most of the cases they train to, reduce their energy consumption after you incentivize them to do it. But after the period where you stop giving them those incentives, they actually bounce back and start just starting from zero and consuming again what they used to consume before, which basically actually makes entirely the point and proves the point that you just made, that actually behavioral change will not gonna cut it unless there is something more than an incentive, or there is something that can control that behavior. And if we talk about this control of behavior, we talk about automation, perhaps. And I would say that because we know that definitely behavior, definitely occupancy in buildings, for example, they drive the demand of the built environment. If we are able to actually control in a better way the production of energy and the consumption through better automation, perhaps we have an idea on how to mix those components of both technology and also behavior to actually take us to those strong targets, actually very challenging targets of reduction of emissions of CO2. What's interesting to see is that COVID actually did a lot of interesting things in this realm, in the sense that on one hand, you could say that it gave some relief to environmentalists and environmental policy itself, right? Because it took us about, diverges out from the very steep path in terms of emissions, at least momentarily, right? So it was a short-term release. As you said, in the long term, or most probably that will just bounce back and continue to grow, right? So in that sense of ideas, you're completely right. It's very, very difficult to say that the changes we're seeing now are going to actually affect in the long term our goals for mitigate emissions of CO2. But if we talk about automation, probably you have heard already this, but this is one of the industries that is starting to actually receive a big boost because of the pandemic, right? There's a lot of new incentives to actually automate many of the things that we didn't know they were possible to automate. There's the opportunity to see that a lot of the workforce that we thought we needed is not necessary anymore, right? We're experimenting with that now. We're actually, many companies are taking this opportunity to evaluate actually how many workers they need to have in the offices consuming energy, consuming resources, right? And how much that affects the bottom line, but also productivity. How much actually that is in reality happening. And I think that type of natural experiment, it never happens in reality. It's something that has never happened in the last, I would say, decades. And so I think there are like different trends, perhaps, that can help us to mitigate emissions. Definitely automation would be one of those, I think. And a lot of research has been invested on that, also companies. So I think that could very well connect both behavioral aspects and technology strategies to mitigate emissions and global warming.
Yeah, you talk about automation. I mean, obviously that is also technology. You consume energy, right? So the argument that say, well, we don't need workers in the office or in the warehouse because they consume energy. But if you're actually replacing them with all the automation, also that it consumes energy as well. So let's say one thing that let's say we don't need people in the office. They could work remotely from home, but actually they consume energy more at home too. My energy bill is way more higher than it was 2 months ago before going into this quarantine. And obviously the offices are not paying for that electricity, but actually office buildings can buy or purchase energy much cheaper than we can. So we have to foot all the energy bill ourselves, which doesn't really come back to us in salary. So, I find that this whole automation is a little bit contradictory because it doesn't really reduce the amount of the consumption of energy. What do you think?
Yeah, I mean that's a good point. Let's speculate for a moment, and let's say I would argue that because of the fact that we have to work from home for a really long period of time, right? And we start to see our bill actually of energy and water also really going very, very high and skyrocketing. That inherently gives you an incentive to change your habits at home on saving energy, right? Because we are now for the first time perhaps noticing that actually it affects you a lot. And it happened exactly the same to me. The first month was double, almost triple the bill. I never realized how much air conditioning you can use, or how much actually my employer is paying for air conditioning. If we talk that in my office, my building, we're about 2,000 employees, right? And we are just two here. So just extrapolating that is gigantic amount of money that employers will be saving, right? That will be on our shoulders, but because we have that extra pressure on our shoulders, that potentially can change behavior. So that could be like an inherent incentive. That could be one alternative that we could see. People just because of the cost that actually is very expensive, they have to do it. Now, of course, that depends on the policies that are going to be coming up next, right? There are countries which already have policies in place, for example, Switzerland, to actually give money back to households for workers that are spending most of their time at home, right? And they incentivize that the employers actually pay them back the utility bills, some percentage to those people. So if that happens, and it happens worldwide, then inherently there is less incentive for people to change behavior at home. Or it takes us back to ground zero. And when I talk about automation is that many of the of the services that we use in buildings and that are controlled by people, they could be optimized through better automation, right? Through better use of air conditioning. There are set points that they are actually optimized with the environment. That the windows are automatically not open all the time or closed. Also the for example the shades are regulated, right? So it doesn't overheat the entire home, and that's something that people do not do quite oftenly. But there are the small things that I think automated systems can really easily do and help to basically reduce the consumption of services like air conditioning at home, right? So I think it will be very interesting to see what happens next and how much policy helps to influence whether households start to actually save energy and the services sector and all those offices closing down basically that will also help to save energy definitely. So that's to be seen.
Yeah, I've seen smart air cons back in like almost 10 years ago in Japan where there were these sensors put on top of the air con. They can sense where the people are going so they can blow cold air, hotter air into that person instead of the whole room. And that technology has been around. But I've never seen it in Singapore or anywhere in the other worlds because obviously those air cons are more expensive and people just want no frills aircon because it's cheaper. Now, do you think that would incentivize people to buy those types of smart air cons or smart appliances going into the future? And then also would offices or employers, I guess, would buy those types of smart appliances?
Yeah, that's a good point. I think looking back at 10 years ago versus today, the prices and costs of those micro components have been reduced dramatically. Also, there is a new wave of do-it-yourself microcomponents and sensors and IoT, basically computing, that you can even do at your home with some small technical skills, watching some YouTube videos. We have seen now that practically all this IoT movement is getting into our homes through do-it-yourself kind of process. Uh, and I will argue that in the future we will be putting sensors in our home as in the same way as we set up IKEA furniture, basically. Because it's becoming very easy to actually manipulate those components and start to interact more with our surroundings. That's basically what's happening. And the more time we spend in those surroundings, the more we're likely to actually try to do something related to adorn it. Before it was about furniture and do it yourself, right? That furniture and that kind of reward that you get when you actually feel yourself doing something. I actually built this closet, right? And now you will see people in the future saying, oh, actually, I built this smart sensor that is sending information to a gateway, maybe 20 kilometers away. I'm watching it in my smartphone. My family is watching and taking care if my kids are okay or not. So grandma doesn't need to be here. She's actually taking a look from her iPad. If things are secure, if eyes are there. And that could be also connected to smart sensors that can also help you to save energy inherently. So I would argue that at a certain point, because of how economic that is becoming, all those micro components and all those that technology is becoming so cheap and so easy to manipulate that we will see them more and more in our homes, in our everyday life. So.
And I presume they're getting cheaper and more energy efficient as well.
Correct. That's actually pretty much where the status of technology is where practically technology related to the Internet of Things is moving forward to having ways in which we can offset the energy consumption of all those smart sensors, right? That we can have a larger bandwidths, perhaps, at a lower energy use. And there is a lot of development that has happened in the last years to make that possible, especially in the telecommunication sector, with new protocols that help you to transmit small bits of data through really long distances. We're talking about even 50 kilometers, and be able to just use it with milliwatts of energy. Just very simple. And I have actually one sensor not with me, but here it's just about 2 centimeters times 5 centimeters. And with one small antenna that is 5 centimeters long, I can transmit temperature and humidity and also solar radiation I get in this room to a tower around 50 kilometers from my location for free, right? Connecting that for free, and it consumes energy. I have it in a small battery that can last providing data for the next almost year or year and a half without recharging. And that's the status today, and we will see that actually is going to become much more energy efficient. That at the end of the day, probably people will just buy those sensors as they buy perhaps bracelets or watches, and they just leave them there and providing you data. How useful that data would be, it's something to be seen. And because we know that there is a lot of data that's going to be being produced because of all these smart sensors and the ability that actually you and me can do it, then that is where automation that also involves the control and the analysis of information is where it enters to play, right? Basically the brain and how to use all that information for different purposes.
Yeah. And I like the fact that there's so many more gadgets out there that are energy efficient, cheaper, and you could do it yourself. And this is really all promising. But let's talk about the energy sources as well. So we've been seeing, over the last 20 years of movement into greener technology. And, how can that really replace fossil fuel energy? Because now that after Fukushima disaster, people are shied away a little bit from nuclear energy, which was probably the most energy efficient energy source available to us, and now everybody's shutting that down and then moving on to these inefficient still greener technologies. And how can they actually really replace what we have right now?
Yes. Well, I mean, all has to do with the question of pricing, right? And we have seen that also during this decade, the prices of, for example, solar energy have dropped about 80% from what it was initially. And technology is becoming cheaper, more available. People are becoming more aware about the need of using. They're not only renewable energy sources, but it's basically free energy, and you can just use it or leave it, right? And because of this movement of do-it-yourself gadgets and electronics, I would argue that in the future it will be very easy for you to also set up your PV installation at home, for example. Today it's very, very simple to do. If you dedicate 5 to 10 hours of video tutorials in YouTube, you can actually do it. You don't need any background on that. Potentially technology is going to be improving, and that means that we can extract much more solar energy for every square meter we get. There are plans for incorporating PV, and not only in the rooftops of buildings, but also in the facades, in the windows. There is technology already there. It's about the price, of course, that it becomes accessible and that we can actually use it. Now, whether the question that will definitely supply all our needs of energy in the future, for sure, only solar will not do it. A combination with wind, for example, with hydropower, which has been actually a very reliable source, could do it. And there is the question that we were pointing out, correct me if I'm wrong, but it's the question about nuclear power. And the idea that if it happens that in the next 5-10 years somebody actually makes it to make a breakthrough in nuclear power technology, potentially all this idea of renewable energy could actually be put on hold. unless the economics of the scale and the price parity between these technologies prove that actually it makes sense to do it. The reason why is because it's all about convenience, right? And while we try people to incentivize to change their behavior, to use solar energy, for most people it's much more easier to worry about many other things that they have in life and then leave that to perhaps the specialists to do it and to supply it through a network hundreds of kilometers away from their locations, as we have done it from the last 100 years. Right? So it's tricky to say whether renewable technologies can help or not. I think they definitely should be in the mix of the solutions. They should be in the portfolio of solutions we need as a society. Whether invest 100% on that is a good idea. I would doubt that because we are seeing that, I mean, the question about technology and more people getting educated about technology, about do-it-yourself applications, about learning online about things that they weren't able to be learning about 10 years ago. That could perhaps bring together a new sort of a specialist, do-it-yourself, or a kind of a specialists that can contribute to develop new technologies in the future. Right? It's not anymore academics who can do it and can think about that.
Yeah, I love to see YouTube videos of how you can make your own solar panels at home with household goods. I mean, that's kind of a dream come true, to be honest. I'd love to install some of those in my house as well. But that's generally for general consumption, and I think that the biggest emitters of carbon emissions are generally more the corporates, right? It's not really just the private households. So when we think about the mixes of energy, you mentioned, there's solar, there's wind and biomass, and it could be nuclear. I mean, there's all sorts of things, but every single one of them seems to be, really consuming the earth as well, right? Because I don't know if you watch the YouTube video about Planet of Humans, which Michael Moore was involved in, somewhere or another, but every single, and I kind of contradict to that movie a little bit as well. Obviously, all the materials that we're using does come from the ground, right? More or less, whether it's wood or fossil fuels or lithium, they all come from the ground. Uranium as well. So we're going to continue relying on the natural resources of this earth, and we're going to continue digging. So when we think about that, since we're digging anyway, let's try to get to the real high efficient energy source, right? I mean, that's the only thing I could think of. And it doesn't have to be 100%, as you say, but what is the most efficient one that is something that we can really look forward to? And I thought it was nuclear. Obviously, they'll need to continue researching. Maybe there are things called like small modular reactors, or they're going to be cold fusion. I mean, there's so many different ones out there, but I think that continue researching this is the most important. I think the Fukushima thing was a matter of not being able to maintain the plant itself. It's not about the nuclear resource, but also it comes with the debris that comes from it as well. How do you get rid of the uranium after they've been used? So what can you tell us about these new promising technologies and this like more high efficient energy sources?
Yes, I think that's I mean, in terms of, for example, nuclear, I will argue that, I mean, there is, probably you have heard about this startup backed up by Bill Gates among other venture capitalists, we can call them like that, on rethinking how nuclear can look like in the future, how we can make it safe. That is mainly the main constraint that technology has. How can we make it safe, and how can we make use of all the waste, all the radioactive waste, right? And it seems like technologies that, for example, one startup company called TerraPower, backed up by Bill Gates, they have a very interesting concept where if they prove to be successful, they can potentially use already depleted uranium which is a great deal because the United States has reserves of waste or depleted uranium that if they're used appropriately with this technology, they could provide these small reactors like energy for the next 100 years. So they claim for the entire United States, just only using waste, not enriching uranium anymore, just using the waste. So that sounds very promising, right? And especially in the idea in regards to what we call the power density, basically how much energy or power you can generate per cubic meter or cubic centimeter of material. When we talk about nuclear, the power density surpasses several hundreds of times that of any other fuel, including gasoline or coal, right? Or natural gas, which are high power density fuels, right? So that makes it very appealing. Basically, you can get more for less, and that idea of getting more for less is what we call efficiency. So so that's why I was saying if those technologies prove to actually escalate to become commercially available, to be as safe as they claim that they could be, then potentially that can turn around all the movement of renewable energy sources. And we have to do it because the goal is not integrating renewable energy. The goal is mitigating climate change and reducing the amount of fossil fuels, right? Uh, Renewable energy is just one way to do it, right? Energy efficiency, energy conservation, other way to do it. But at the end, the goal is basically reducing the amount of fossil fuels um, and providing secure and affordable energy for everyone. Right? That's pretty much the goal. So I think that technology is very promising. That's called the travel wave reactor, if I'm not wrong. Um, and what it makes it also secure is that it operates at about 200, 300 degrees Celsius, which is not too high in relation to what normal reactors operate, like at what temperatures they do. And, and the lower temperature those reactors operate, the easier it is to cool them down in case that something gets wrong, basically. So that's the main idea. Um, and that's why those kind of reactors could become promising. You just mentioned the idea of this cold fusion that has been there for a while. Potentially, it doesn't exist too much in research anymore because although it promises a lot, basically cold fusion comes from the idea that you can fuse two atoms at room temperature, right? Basically have energy for free at room temperature, right? Which physically can be possible, but in practice, apparently just a few experimentalists have been able to do it and generate just small amounts of power. And we have seen that that technology started about 20 years ago to be explored. 10 years ago, the Department of Energy of the United States started to also to try again what to do with that, but apparently it was not easy to replicate anymore. And the problem that if we can replicate experiments with any technology, then we cannot escalate them and we cannot make products out of it. So I think that technology is pretty much dead as of now. And perhaps the safest bet is those small reactors, more compact reactors with this travel wave technology. There is also the molten salt reactors that also work in a compact way, not as big as the other ones. And I think it will be very interesting to see what happens in the next years. I mean, for example, these TerraPower startups say that they were not able to actually escalate the technology now. They have it ready. It's 2015, and they signed an agreement with China to actually make some reactors, the first ones. And apparently, because of the trading agreements and all the trade war with the Trump administration, it was not possible to actually build those reactors outside of the United States. And in the United States, there's not legislation that approves actually those kind of safety requirements needed to experiment with this high risk at the moment, but high reward technology. Um, And of course, there is the issue of perception, right? Of, as you said, probably this generation got very affected for what happened in Fukushima, right? Perhaps the next generation will completely forget about it, and they would be potentially more open to look at nuclear once again. And,
Yeah,
and
I hope so.
that potentially can happen. So I think it's to be seen what the future will hold.
So when do you think the travel wave will be available?
Well, according to, I mean, these companies, I mean, what they estimate is that the technology is available now. It just has to do with these trading agreements. So uh,
So it's pretty much
it's
any
difficult
time.
to,
I mean, it's more of a
it's
political issue
difficult.
than anything else.
I would argue, yes, it would perhaps be connected to what happens in the North American elections, right?
Right.
If
But do they?
Trump gets a second term and that policy of uh, basically is being maintained or not, you know.
Does it have to be with China? It could be with Europe or Japan or someplace in South America. I mean, why does it have to be with China?
Well, believe it or not, China, the great thing about China that not too many people like to accept is that they managed to create a workforce and a system that can quickly reproduce a design and just scale it up uh, to a big market, right? And the Chinese market is really big. It just comes with the population, right amount of population, the legislation that allows you, in a top-down idea, say, hey, we're going to experiment with this if they want. Um, you can invest a lot of money and dump it into this type of strategies, and you come with a workforce who can do it, right? So that's why it makes it very special to do that. And we're talking about reactors that cost billions of dollars to build. Right? So that investment has to be there, and also not only the capital but also the people to do it, right? And to do it fast. And fast is especially important because if we want to attain those goals by 2050, we have to actually scale them as soon as we can, and potentially while they are scaling them, they have to learn and do iterations and improve them as it happens with any other technology. So I think that's why China became really attractive for this company to invest on. I don't see Latin America and South America having those capital in terms of knowledge and manpower to do that. Europe may have it, but the costs can be astronomically huge, as well as in North America. We can think about India. There are good engineers there, but still the capacity to produce, to also extract raw materials that you would need for those type of reactors, right? And build up the technology and all the supply chain of India doesn't compare to that one and the organization that China holds right now. Yes, so I hope that answers your question, right?
Yeah, it totally makes sense. I mean, China will always be the country that has the power or the money to throw it at its people and then grow this type of industry. I mean, it's probably the same with AI or blockchain or many of these other new technologies that it's out there. They could just print money out of nowhere and just continue building these things. So I think that it is promising. I believe that in the next decade or so, hopefully we can see more energies, not just green energy, but newer technology using nuclear fission to create more efficient energy into our lives. So thank you very much for your talk. I mean, it was very interesting and saw a little glimpse of the future. So thank you.
Hey, my pleasure, Taka. Anytime.
Hi, this is your host Takatoshi Shibayama. Thank you for listening all the way to the end. Now, if you enjoyed or disliked this show, please let me know by writing in the comment section. The only way I can improve or add value to you is through your voices. If there are any topics that you would like me to pick up, please also let me know in the comments. I'd love to start chatting with you all. And if you would like to continue watching the show, please subscribe. Thank you.